negative x. So it's going to be 3 times x is going to be replaced by negative x. So 3 times negative x is negative 3x.
Odd.
Is that f of x or negative f of x? Negative.
F of x.
Correct. So you can say the function is odd. Okay. Next question is, g of x is 2x squared minus 6. Again, our first step is replacing.
That would be even, right?
Let's do it, Joe. Just replace the x by negative x. So it's going to be 2 times negative x squared minus 6. So mainly you replace the x by negative x. So negative x quantity square is same as x squared. Minus 6. The minus 6 is not changing because there is no x there. Okay, now go ahead. Is that your g of x exact same as g of x? Okay, so this is your g of x. So when you replace the x by negative x and you still get g of x, is that odd or even?
Even.
Even function. Okay, next question, same thing, you're going to replace the x by negative x. So 3 times negative x squared minus 2 times negative x and plus 4, which is negative x squared is same as x squared. Negative 2 times negative x is plus 2x. Both negatives, when you multiply, get a positive number, and plus 4. Now, how would you compare this with h of x? If this is h of x, can you tell me what would be negative h of x?
Negative 3x squared plus 2x minus 4.
Correct. Because every single term is going to be the opposite. Negative h of x should look like this. And h of x should look like this. Look at your answer. Does it look like any of those?
No.
Everyone, does it look like any of those?
No.
Wait, so Miss Johannes?
Yeah.
So would the function would it be even only if like the x term in the function is raised to like an even power?
Yeah. Everything has to be even powered, or everything has to be odd powered to become the odd function. Okay, but this is what you do algebraically to check if a function is even or odd. So example number 1, all 3 problems, is that clear? Everyone?
Yes.
Yes. Yeah.
Yeah.
Now let's get into the real topic of the lesson, which is how are we going to graph if the function looks like this? And I want you guys to look at it very carefully. Look at this. See the form? It's a little different than what we have seen in the other 3 lessons. We are going to call this form vertex form. Vertex form. Okay. Now, do you guys remember what's a standard form? Can one of you tell me what is standard form?
It's just like the quadratic equation.
Yeah, what is that?
Ax squared plus bx plus c.
Correct. So that's the standard form, and this is the vertex form. The reason this is called vertex form because you can easily identify the vertex from this form. The vertex is going to be h, k. This h right here is the x coordinate of the vertex. The k that is outside, like the vertical shift up and down thing, that's actually your y coordinate of the vertex. So the reason this is called a vertex form is because you can easily identify the vertex from the equation itself. The vertex is h, k. Okay, let's look at the right side of this. The vertex form of a quadratic equation, and I want you guys to memorize this. Memorize this. Y is f of x is equal to a parentheses x minus h quantity square plus k, where a cannot be 0. If this is the form, then the vertex is h comma k.
What number? It's algebra.
Okay, h comma k, and the axis of symmetry is the x coordinate of the vertex, so x is equal to h. Okay, really quick, I want you guys to memorize these 3 things. 1 minute. Okay, ready? So, what is the vertex form again?
H comma K. Oh wait, no, the other one.
A
F
times
X
x minus h squared plus k.
Correct. And you can easily identify the vertex. This is h comma k, but don't get confused with this negative sign. The form is x minus h, but then you only take the h there, h comma k as the vertex, and the axis of symmetry is equal to h. Okay, example 2. In example 2, you're asked to identify the vertex, axis of symmetry, domain, and range of each quadratic function. You guys are familiar with this. Now we are only going to make the connection with the vertex form in this lesson. Okay. Tell me, what is the value of h in this problem? So look at this. I'm just going to write like this. X minus
Negative
h.
4.
4.
Okay, just look at this. X minus h. What is h replaced by in the problem?
4.
4, right? So h is 4, not negative 4, and k is equal to?
3.
K, it's supposed to be plus k, but we have negative 3, so k is negative 3. You should always be comparing with the a parentheses x minus h quantity square plus k. And exactly, just do the right comparison, a direct comparison, and then h is equal to 4, k is equal to negative 3. So we are going to answer the question. Our vertex is 4 comma negative 3. Okay. Axis of symmetry is x is equal to 4. I'm just going to write axis. Symmetry is x is equal to 4. Domain is all real numbers. Range is, you guys tell me what the range is.
Oh, y is greater than or equal to -3.
Correct. Y is greater than or equal to negative 3. Oh, by the way, does this parabola open up or down?
Up.
Up.
Up. That is why we are having greater than or equal to. Okay, so this is up. Okay, let's try B. Look at the equation and tell me. Okay. Does this open up or down?
Down.
Down.
Because of that negative sign. Okay. Again, we're going to write A. This is X. Is supposed to have negative H and then plus K. Okay. So what is H in this problem?
-2.
Correct. We're supposed to have x minus, but we are having a positive. So this can be rewritten as this, x minus -2. So your h is negative, or you just take the opposite of what you see there as h. But k is supposed to be the same thing. K is equal to 4. You have to flip the sign for h, but keep the sign for k. So the vertex is -2, 4. Axis of symmetry is
-2.
x is equal to -2. Domain is all real numbers. Since this parabola is going to open down,
Y is less than or equal to +4.
correct, y is less than or equal to 4 because y is the range, y value is the range. Are there any questions? Okay, now let's do one graphing. Okay, and then we are going to compare the graph to f of x is equal to x squared. Okay, now listen carefully. If you want to graph this, there are several ways you can graph this. Number one, you can make a table of values. Okay, and number two, you can graph the way we learned for the standard form, that you find the vertex, you find the axis of symmetry, you find the y-intercept, plot them, and all those things. But I'm going to show you guys a third way to graph this one. Now, by the end of the chapter, you have several ways to graph a quadratic, and you can pick and choose whatever that's convenient depending upon the problem. All right, so first I want you guys to graph the axis of symmetry. Okay, what is the axis of symmetry here? X is equal to, what is the vertex?
2,
-2, 2.
-2.
Negative. But it's supposed to be x minus h. You have to flip the sign for h.
Yeah.
So the axis of symmetry is going to be x is equal to
-2.
-2. I want you guys to graph it first. Use dashed line for the axis of symmetry. It's going to be, let's see. Okay. Now I want you guys to plot the vertex. -2, 2. Next, plot the y-intercept. What is the y-intercept here? Now listen, to find the y-intercept, you guys are going to put the x is equal to 0. When x is equal to 0, g of x is your y is equal to -3 times. That's how you always find the y-intercept. But in the standard form, it was easy to find the y-intercept because that was the constant term. But don't get confused here with 2 as a constant term. That's not the constant term because you will get another constant term by the expansion of this. That's why I'm going to follow this method. So when you substitute x is equal to 0, you get the y coordinate, and that's the y-intercept. So what is that?
-10.
That's correct. The y-intercept is -10. So I want you guys to plot the y-intercept, which is 0, -10. Let's plot that. Are you all with me?
Mm-hmm.
Okay.
Yeah.
We are going to plot the y-intercept 0, -10. Which is, I'm going to assume that that's somewhere Okay, I'm gonna say it's here, okay? It's not, but let's assume that it's there. Okay, now once you get the y-intercept, remember I told you yesterday that you can reflect that point across the axis of symmetry to the other side.
Yep.
So from here to here, the distance is 2, so it's going to be right?
-4.
Yeah, that's correct. Very good. You always, every time you find a point on the parabola, you always flip it across the, reflect across the of symmetry to get an extra point. Now I want you guys to pick one extra point. Pick an extra point. Okay, I'll tell you how to pick the extra point. Look at this graph. You got the vertex, you got the y-intercept, you flipped it across the axis of symmetry, you got that. Now, do you see that this is the value corresponding to 0? Do you know what is the y value when x is equal to -1? Maybe you can take that as the extra point, right? So you're going to figure out when x is equal to -1, what's your y value? Because I'm just curious to know what's happening here for the graph. So let's find out what happens when x is equal to -1. Your y is 3 times -1. You just have to substitute there into the function, which is -3 times 1 square plus 2, which is -1. So therefore, you got an extra point, which is -1 comma -1. Did you all get -1 comma -1?
Yes.
Okay, let's plot that now. Let's plot that point. We have -1, -1. So it's right here. Now, every time you pick a point, you can flip it across the axis of symmetry. So that gives you an extra point. Where would be this point be if you reflect across the axis of symmetry?
-3 and -1.
Correct. So here you go. Now, how many points do we have on the graph?
5.
This is what I'm looking for. If you have test or something, you have to give me 5 points. So let's connect. Do you want to do one more like this?
No.
You guys get it, right?
Yeah.
Okay. Or just watch the video again if you have any trouble when you do the homework. Okay. Example 4. So we learned what is the vertex form. We learned how to graph it. We know how to find the axis of symmetry, the vertex, the extra points, and everything. Now they are asking, can you come up with an equation if I give you some stuff about the quadratic function? So let's read this. You're asked to write an equation that models the path of a stream of water with maximum height of 4 feet, represented by a vertex of 3, 4, landing on a spotlight 6 feet from the water jet, which is represented by 6, 0. These are the things that's given to you, and you have to come up with an equation like this. You're asked to come up with an equation like this. Can you come up with something like this? Okay. So let's see. I want you guys to write the vertex form first. Y is equal to A parentheses X minus H quantity square plus K. You're starting off the problem with just the vertex form. Now tell me, what is H comma K in the problem, which is the vertex? Is that given to you? Is the vertex of the parabola they are looking for, is that given to you?
Yes.
Which is 3, 4. Okay, let's just substitute that into the problem. We have no clue about A, which is fine, A. But we know that H is 3 and K is 4. So we just substituted the H and K into the problem. Okay, so we used this information. How are we going to use the 6, 0 in the problem? Okay, now I want you guys to notice that we're talking about the path of a stream of water from a jet, correct? Okay.
Wait,
So
you could. Sorry.
Yeah. So this point somewhere, it says that landing on a spotlight 6 feet from the water jet. If this is the water jet and this is 6, then it's going to be 6, 0. Is also a point on that path.
So
So you
So you
could
can,
the
yeah,
axis.
go.
you could sub in 6 for X and then wait, actually never mind.
Yeah, you're right.
Oh, it's 6 for X? Yeah.
Okay. Then 6, 0 is on the path. Let's just use this as your X and this as your Y, because that is actually a point on the path. Okay. So we're going to substitute Y is 0 because we're trying to find what A is. If we find A, we have the equation and then we are done with the problem. But right now we don't know how to find the A. But then we notice that there is an extra point given to you in the problem. Let's use that. A is equal to X minus, not X is 6. 6 minus 3 quantity square plus 4. 0 is equal to A parentheses. This is 9 plus 4. And you are asked to find what A is. So you subtract 4 first. We have -4 is equal to 9A. Divide by 9 on both sides. Therefore, your A is equal to -4/9. Now, if you go back and read the question, it says that write a quadratic equation. We got the equation now. Therefore, our equation is Y is equal to, and it does make sense. You see that you're actually getting a negative A value, which means it's upside down because the stream of water cannot go upward, right? This is your equation. -4/9 parentheses X minus 3 quantity square plus 4. Okay, I'll explain the steps one more time. You're going to write the form first. You substitute whatever that's given to you. The only missing thing in the problem is A. And that is why that extra point is given to you. You substitute, you find the A and substitute back into the equation to get the equation of the quadratic function. Is that clear?
Yeah.
Yeah.
Hey, we forgot one thing to do in example 3. We are asked to compare the graph. We didn't compare it, we only grabbed. Let's look at the graph or just look at the function and think about the comparison. I'm going to write it down. Compare or comparison. Okay. Okay, how would you take care of this negative in front of it?
Factor it out.
You see that you're comparing with f of x is equal to x squared, correct? F of x is equal to x squared is actually a graph that opens up. Since there is a negative and you see that your function is opening down, so the negative is reflection across the, do you guys forget this?
No.
Do you remember we talked about this yesterday? If there is a negative in front of it, that's a reflection across the x-axis. So that is one we are comparing. This is happening. Okay, and then how do you take care of this plus 2 that is with the x inside the parentheses?
Left 2.
Correct. You're going to say there is a horizontal shift left by a factor of 2 or left 2. Now we need to take care of this plus 2, which is what?
Up.
Vertical shift up 2 units.
2 units. Okay, so that's how you do the comparison. When they say comparison, I want you guys to describe the transformations. Is everything good?
Yes.
Yeah.
So that's the end of 8.4. Are you guys keeping up with all these homeworks and everything?
Yes.
Yeah.
Okay, good job. Good job. Are there any questions before we end the meeting? How are you guys doing?
Good.
Good.
Doing
How about you?
homework.
So meet tomorrow also around the same time. Listen carefully, but next week onwards there will be a change in time. Because March 30th, school is planning to have a certain time, a scheduled time for each department. And math department got the time from 11 to 12, which means I need to finish all my classes, but that's not going to be possible because I have 2 courses that I'm teaching. So for you guys, I'm thinking of 12 o'clock. Is that clashing with anyone?
No.
No.
This is my only online class.
So then I got the time from 11 to 12, but 11 to 12 I'm going to do for my calculus, and you guys, I will meet at 12 o'clock, okay? Not 2 p.m. Starting March 30th, not tomorrow. Tomorrow is still 2 p.m., okay?
Wait,
Okay.
so when would our first class be?
Hmm?
Are they gonna start are the classes gonna start from what time? Like 9 or what?
I didn't check what is for other department. I looked at the map.
Oh,
Did you guys not get the schedule though?
No.
No.
Okay, I thought they sent you. Check. You must have gotten something last week.
No, I don't think so.
Yeah.
Nothing.
they haven't sent us a schedule.
What is that?
The only thing they sent out was that school is closed till another month.
Yeah.
It's 11 to 12. It's 12 to 1 every day or just Mondays and
Monday, Wednesday, Friday, but not Thursday though, because math is Friday, so I have to go with the Monday, Wednesday, Friday, starting March 30th. Okay, so it's going to be right here. You tomorrow at 2 p.m. Next week onwards. Next week, Monday, Wednesday, Friday at 12 noon.
So is it 12 to 1 or 12 to 2?
No, 40. I think I'm only going to go up to 40 minutes because we only got 1 hour now. I'm asking extra, so I think I have to limit 40 minutes.
Okay.
Okay?
Yeah.
Okay, all right. So I'll see you guys tomorrow at 2.
Bye.
Bye. Take care. Do the homework. Make sure that you correct the work, okay?
Mm-hmm.
Mm.